So just to reiterate some of the principles from the last slide, let's discuss helper T cells again. CD4 T cells may either differentiate into Th1 cells, Th2 cells, or Treg cells. Th1 cells and Th2 cells are more important for your exam purposes, however. Alright, so let's review. Th1 cells. Which other immune cells do they stimulate? Primarily macrophages, as we see here, and B cells. They induce class switching to make IgG. So let's say we have a macrophage here that just ingested a juicy bacterium. All right, it grinds it up and sticks a section of it on its, what type of MHC complex is this? On an antigen-presenting immune cell. It's MHC2. And if you recall, the product of the MHC receptor and the type of T cell must equal 8. So that's why this must complex with the CD4 receptor on the T cell. There's another stimulating signal between receptors of the B7 on the macrophage and the CD28 receptor on the T cell. So that's co-stimulation right there. Additional encouraging signals and stimulating signals are cytokines that are released from both cells. The macrophage, which you can think of macro with this alpha, macrophage, it releases TNF alpha. The T cell releases, so that stimulates the T cell, and in turn the T cell releases interferon gamma that co-stimulates the macrophage too. You can remember interferon gamma is released by the T cell because the gamma symbol, if you bend this middle part up a little bit, kind of looks like a T for T cell. Th2 cells, recall Th2 Achu, so they induce the class switching of B cells from making IgM via interleukin 4 and 5, then making IgE. Again, the IgE is deposited on the surface of mast cells. An allergen, once exposed the second time to an allergen, like a piece of pollen or something, cross-links these IgEs, sends signals to this mast cell to release its contents, and you have the propagation of an allergic reaction. So recall that cytotoxic T cells are pretty similar and analogous to natural killer cells, except that natural killer cells are non-specific. Cytotoxic CD8 cells are more specific and more of the adapted immune system, while natural killers are part of the innate immune system. Okay, so here's an example. This is pretty much a review at this point, but a virally infected cell is detected by the CD8 receptor bearing T cell, and it complexes here with the 8 times 1 is 8, right? MHC1 and CD8, and it complexes here with the fast ligand CD95 receptors. These are just things you got to memorize. They'll stick eventually. But this induces co-stimulation with the help of other T cells, specifically the Th1 cells, for the most part, releasing pro-T cell cytokines. Say, come on, buddy, you can kill that tumor cell or that virus-infected cell. Interleukin 2 is the T cell interleukin. And then we have the cascade of apoptosis. Later on in your first aid text, you'll see a wide variety of autoimmune diseases that all wreak havoc on multiple organ systems, sometimes simultaneously due to misdirection of the body's normal immune response. So here's a Treg cell. These regulatory T cells help keep that autoimmune progression from happening by suppressing unwanted immune activity. They do this by inhibiting the CD4 and CD8 T cell functions via an anti-inflammatory cytokine such as interleukin 10 and TGF-beta. They express certain receptors, CD3, CD4, and CD25, that you can use to specifically identify this type of T cell. So moving on from differentiation, we're now going to talk about T and B cell activation. And this can be simplified on the basis of various cell surface markers. Now, we've mentioned several antigen-presenting cells. Do you recall any of them? How about macrophages? Two more major ones are dendritic cells and B cells. Okay, so recall from your immuno courses from med school that there are two signals required for both B and T cell activation. For T cell activation, after a foreign body, such as this bacterium, is phagocytosed by an antigen-presenting cell, as we see in this macrophage here, this fragment of this ground-up bacterium is then presented on the surface via what type of MHC receptor? 2. That's right. Okay, so 4 times 2 equals 8. Okay, we know we have to equal 8. So what type of T cell will this macrophage want to connect with? That's right, the CD4 T cell. Now, the joining of these two receptors is the first signal. Okay, CD4 with the MHC2. That is signal number 1, but recall that we need 2 signals for co-stimulation to occur. And that is accomplished by the B7 receptor on the macrophage joining with the CD28 on the T cell. That is signal number 2. And you are just going to have to commit these to memory. It helped me to know for some crazy reason that 7 times 4 equals 28. So maybe that will be a helpful mnemonic for you. Okay, so after both signals are received, helper T cells are able to secrete cytokines, right? And the macrophage releases its cytokines too. Real quick test, what type of cytokine is released by the T cell? Remember what kind of looks like the shape of a T? It's that interferon gamma. You can kind of stretch this up to make it look like a T. All right, so that is co-stimulation between the CD4 T cell and the macrophage. Both are just amped up and ready to do their jobs, ready to be soldiers. Now, how about B cell activation? B cell class switching also requires 2 signals. So recall that the T helper cells release cytokines to induce class switching. It just depends what type of TH cell it is, either 1 or 2, that will determine what type of antibody these B cells will class switch to. All right, so a B cell is an antigen-presenting cell, and it will present this antigen via the MHC what receptor? MHC2, just like we saw with the macrophage. It'll complex with what receptor on the T cell? The CD4, and that is signal number 1. But now we still need another one, right? There's always 2 signals. So the second one is the interaction between the CD40 receptor on B cells and the CD40 ligand receptor on the T cells. Generally, the T helper cell that is activating a B cell was itself just activated by that same B cell, since B cells act as antigen-presenting cells. It's also worth keeping in mind that it's the cytokines secreted by the helper T cells that determine the antibody isotype to which B cells switch, as we just said before. So these cytokines, you know what they are? It depends what type of T helper cell it is. What about for T helper type 1? The cytokines would be interleukin 6 to induce the class switching of IgM to IG. What? IgG. If it's T helper type 2, the B cell will class switch to IG, E. Th2, Achu, allergy, IgE. Okay? Kind of helps you remember all those things grouped together. And the interleukins that induce that from the Th2 cell are interleukins 4 and 5. So this is probably the easiest flash quiz of your life. What do B cells synthesize and release? You better know that it's antibodies, and I am just checking to make sure you're all awake.